Good afternoon, everyone. My name is Thomas Al. I'm the facilitator for the Sierra Club Pennsylvania chapter's water quality team. And today we have a special session. We have a webinar on all things PFAs with regard to drinking water. And with us today are Dr. Faith Kabouye from the Penn State Co-op Extension and Matt Fitch from the Philadelphia Water Department. They'll be talking about what work they've been doing on detecting and treating and educating people about PFAs in drinking water. And this session will be recorded for a few attendees who cannot join us at this noon hour. So without further ado, I'll turn it over to Faith. Thank you.
For the introduction, and I'm going to share my screen now. Let me know when you see it.
There we go.
Okay. Thank you all, and good afternoon. I'm very delighted to be with you here today, and thank you for the opportunity to share some of our research and also just general information about PFAS. So we'll do that. So to start us off, I wanted to give just a basic overview of what PFAS are. So PFAS is a group terminology and also an acronym that stands for per and polyfluoroalkyl substances. So it's a term that is used to describe a really broad class of chemicals. That it's estimated that it's about tens of thousands of chemicals that can be classified as PFAS. PFAS tend to have a common general structure, and they often consist of a long carbon and fluorine chain, whereby we have carbon molecules that are strongly bonded to the fluorine molecules. And so different PFAS have different numbers of carbons in that tail. And apart from the carbon in that PFAS molecule tail, the tail of the compound is also typically attached to different functional groups that are commonly known as the head of the compound. These functional groups provide individual PFAS compounds different properties that make them desirable for a variety of uses that we will share in the next coming slides. There are a variety of PFAS, and so therefore scientists are trying to group them based on the number of carbons on them. And so, for example, PFAS that have 4 to 7 carbon molecules in the tail are commonly referred to as short-chain PFAS. And here are some examples of common short-chain PFAS. And then we have those that are known as long-chain PFAS. As the name suggests, they are long. They have a large number of carbons in them, typically about 8 to 12 carbons in the tail. And the common ones that you probably have heard of are the PFOS and PFOA compounds. These two have since been phased out, but because of their typical characteristics and frequent use, they're still being detected in the environment. And so I mentioned earlier that the characteristics of the PFAS compounds are very unique. They are used to provide different properties to the individual PFAS characteristics. And therefore, some of those properties include the ability to repel water, oil, and stains and on different surfaces. And then some of them also have what is known as thermal stability, to insinuate that they have the ability to maintain their mechanical characteristics even at high temperatures. So There are a variety of PFAS, but they've been used for a very long time. In this slide, we were just trying to capture the wide variety of industries that make use of different PFAS molecules because of their different properties and chemical characteristics. So those range from building and construction materials to some of our common consumer products like textile or clothing materials that have stain or water repellent properties. They're also commonly used in fire prevention. The P4 and PFOS, the long-chain PFAS, were very frequently used in this fire prevention side to put away high fuel fires. And then we have other industries like the transportation industry, common uses in packaging, among many others. And so to make it more simple, these are just some of the consumer products to make it more relatable in our day-to-day activities. So our products that are non-stick, for example, the non-stick cookware, waterproof clothing or apparel, stain or water-resistant treatments that sometimes we end up needing. In order to get that property of being stain or water-resistant, they're using some type of PFAS compounds. And so because they're widely used, the wide use of PFAS, they have a variety of pathways that they can get into the environment. They can get into the environment throughout the process when they're being manufactured, when we're using these products, or when we're tired of using them, or they've reached their shelf life and we dispose of them. During all that process, they can be introduced into the environment. In this slide, we are showing some of these common pathways, and examples are wastewater discharges, where insufficient treatment of wastewater can result in PFAS exposure to receiving aquatic systems, or in some cases, it's biosolids. Another pathway is leachate from landfills or other use of sites where we've been using the firefighting foam, among many others. And so we are exposed to PFAS through a variety of ways. And the common pathways that we have are exposure through drinking water. Ingestion is a common pathway, so it's either drinking water or food as one of the major pathways of exposure. Another one is inhalation of particles that may contain PFAS, and some potential pathways, for example, could be dust particles from carpeting that may contain PFAS coating, or in some cases, it could be in developed areas that may have other particulates from various sources that may have PFAS in them. PFAS exposure has been linked to a variety of human health concerns. Some of those include PFAS being associated to difficulty becoming pregnant, chronic kidney disease, cardiovascular disease, and some of the common PFAS compounds like P4 and have been classified as potentially carcinogenic. This is to mean that they have the ability to perhaps increase cancer incident risks, or make people vulnerable to different types of cancer. So it's worth pointing out that the extent of human health impacts can vary, and some factors that might influence that human health effect could be the types of PFAS you're exposed to. We talked about earlier that we have a variety of PFAS, and there are so many, and that means that we may be exposed to different types at a particular time. Apart from the types of PFAS, the other potential factor is how much of those PFAS we're exposed to. So do we have this common saying that the dose makes the poison? That still is applicable here. So the exposure amount is still an important factor to consider. And then duration of exposure, how long you were exposed to it, whether it was just one incident or you've been exposed to some PFAS throughout your life. Another last factor is our individual characteristics, our genetic characteristics as well could also play a role on the overall impacts of PFAS, the different PFAS that we might be exposed to. So because of these health effects, regulatory agencies are taking some type of action to protect human health. And some protection, some legal action has been going on the drinking water side. For example, the state of Pennsylvania in 2023 established drinking water maximum contaminant levels of P4 and PFOS. So maximum contaminant levels refers to the highest amount that they can legally allow to be present in drinking water. And this is established using some studies of risk assessment estimations and also human health exposure risks. And so this MCLs apply to public or municipal drinking water systems. Earlier last year, US EPA also finalized drinking water standards for 6 PFAS, and their limits were much lower than those that we saw in the previous slide. But a common factor is that the US EPA standards also apply to only apply to public drinking water sources. So let's talk about public versus private drinking water sources. So public water systems are those utilities that serve at more than 25 people throughout the year. There are different types of public water systems. Some are we are more familiar with the community water systems. Others are known as non-transit community water systems that are only serving regions such as schools or factories, while some are known as transit or non-community systems that serve in places like gas stations or campgrounds. So private water systems only serve people, individual households. And this map of Pennsylvania is just showing us the areas within the state that are served by public or municipal drinking water, the shaded areas in blue. This is to imply that the white areas are areas where people have to depend on private water supply. And so to go back to regulatory of PFAS, so the US EPA drinking water standards were passed in 2024, but utilities have been given some time to assess their water quality status with regards to PFAS levels, and then have to implement treatment by 2029. Testing for PFAS is relatively expensive, and there were some guidelines, especially to small and rural systems, to help reduce the burden of when it comes to PFAS testing. And so, for example, right now, surface water sources are monitoring quarterly within the year, but small water systems have avenues of reducing their monitoring frequency if they are dependent on groundwater sources, or if they've collected water in the past that have shown that their PFAS levels are low, then they could reduce their monitoring frequency. And this can help reduce their overall testing load or cost when it comes to the regulatory of PFAS in drinking water. So when it comes to testing for PFAS, there are a variety of methods that have been implemented. The US EPA established method 537.1 that tests for 18 PFAS. We have the 533 that tests for 25 PFAS, but also the 1633 that also tests in non-potable biosolids and leachate. Overall, if we look at the method 533, they have what is known as a reporting limit. And reporting limit is the number that a lab can confidently tell you that compound X is there and they're sure about it. We see that the reporting limits are very low, but they're very they're very close to the final MCLs, the maximum contaminant levels that were established for different PFAS. However, thanks to improvements in analytical technologies, we are seeing that most laboratories are able to meet this method reporting limits and detect concentrations of PFAS at very low levels. So the next few slides, I'll share some data with regards to occurrence of PFAS in surface water sources. So this is a USGS study that monitored Pennsylvania streams, and they were finding that PFAS are indeed prevalent, and they are finding at least one PFAS compound present in 76% of the streams. Then this map is showing total PFAS concentrations. We see that there are areas in that we cannot detect PFAS, but there are areas that have total PFAS concentrations as high as 100 nanograms per liter. Through Penn State University researchers, we've also monitored private water systems for different PFAS concentrations, and the concentrations, just like the surface water sources that were monitored by USGS, concentrations varied between site to site. We have sites that did not detect any PFAS at all, but we also have wells that have more than 125 nanograms per liter of total PFAS. Total PFAS is just the sum of all PFAS that were detected at a particular site or sample. In this table, we wanted to show how frequently the groundwater samples were exceeding existing standards, and we comparing concentrations to PADEP standards. Only less than 5% of the samples were exceeding the PADEP rule for P4 and PFAS. We have slightly more samples failing US EPA MCLs, but we also shown earlier that the MCLs, US EPA MCLs are much lower. But we were delighted to see that not many sites were exceeding this drinking water standard. And so to touch a little bit about treatment, I know Matt will focus on this, but there are technologies available to remove some of these PFAS that are present in water. Regardless of whether you're in public water systems or private water systems, if you are thinking that you want to treat your water further, these technologies can be available at a point of use where it's maybe at their tap water, or for private well owners, they might need treatment for all the water coming to the home. For example, if that is the case, they might end up choosing to go with point of entry water treatment services. If you're buying any of these, pay attention to look for National Sanitation Foundation certified products, or those that are certified with the Water Quality Association. So if you are trying to assess your risk before you implement any treatment, it's important to assess if you really need that treatment. So if you're on public water, it's very likely that your utility is already doing some type of testing at this time for PFAS. So you could call and find out what those numbers are, but this could also be sent to you in your consumer report as a public water system user. If you're a private well user, the responsibility of testing your well and maintaining it and protecting and treating it if there's an issue all fall on you. And so if you're worried about assessing your risk, it's important to test your water. There are some Pennsylvania DEP certified laboratories that are available for PFAS testing. When you get your results, PFAS are very prevalent. You're probably going to have some detections of PFAS in your water. And however, that does not mean that the detection is ultimately a problem. Take the time to compare your results with federal drinking water standards or state drinking water standards, and use that as a point to establish if indeed you need some of those treatment devices that I was sharing in the previous slide. And so besides water, we mentioned earlier that you might have other exposure through food. So if you're concerned about fish consumption, take a look at Pennsylvania DEP consumption advisories. And this you could either look up on their website, or you could reach out by calling a phone number. And if you are aware of a site that is heavily contaminated with PFAS or any other contaminants for that matter, you can reduce or avoid eating fish from those locations. And follow consumption guidelines. Right now, we don't have any advisories listed yet for PFAS, and I think that's a good thing. But beyond the consumption of fish, if you are concerned about some of the products in the home, so this could be some like carpeting. So there's a lot of regulation activity around PFAS right now, but we may have still previously purchased compounds that may contain these products. So if you're trying to find out more about the products that you have in the home and the ability to expose you to PFAS, there is a number. It's called the Consumer Product Commission's ombudsman number that you can reach out to and ask more about it. It's the number is on the slide here. And so I also wanted to end by sharing there are advocacy needs, and some of those include a lot of the burden can fall on consumers or even utilities, and they're not necessarily the producers of these PFAS. So some needs are source control of PFAS and pollution prevention, and then and identifying vulnerable communities, those that might be marginalized when it comes to PFAS testing, cleanup efforts, or health intervention. So identifying and working in those communities. This is not an all-inclusive advocacy need list, but these are some of those that I thought I could share with you all today. And with that, I wanted to end by sharing that visit us at Penn State Extension and Penn State University. We tend to have a lot of resources or events that revolve around PFAS, among other things that we have. One event that is ongoing right now that I wanted to share is with the SAFES Institute. They are hosting a publicly available webinar series about PFAS, where they're highlighting different research being conducted across the university. I'll put that link to that event on the site, on the chat after this. But thank you all, and I'll pass it back to Mark.
Well, thank you. Thank you, Faith, for this great overview and the practical advice that you've given us. I just forgot to mention, we will take questions at the end after Matt presents his materials. And if you could, as the audience, put your questions into the chat, maybe I can group some of the questions to a thread that makes sense to our presenters. Okay. So now we'll turn it over to Matt Fritsch from the Pennsylvania City of Philadelphia Water Authority. Thank you.
Thank you. And can you all see my slides here?
Yes.
Great.
Very clear.
Thanks very much. So first of all, thank you to Dr. Kabuye for that information. I think you'll find that our information overlaps a little bit, but complements each other. So again, my name is Matt Fritsch. I'm an environmental engineer with the Philadelphia Water Department. I began studying PFAS around 2018, so it's been a journey. And so today I want to kind of give you the water utilities perspective on what is happening with PFAS. So here's a quick disclaimer that I have to show. And for those of you who may not, be around the Philadelphia region, I just want to give you a quick background on the Philadelphia Water Department. We are the largest public water utility in the state of Pennsylvania, and we serve about 1.6 million people. And that is a one water system, which means we provide drinking water services as well as wastewater and stormwater. And along with the wastewater goes a biosolids production facility. So if you don't know what biosolids are, I'll touch on those later. But PFAS touches in some way all of our water systems. We're a large utility, as I said. We have 2,000 employees. So when something new like PFAS comes up, it means even internally trying to educate our own workforce about PFAS. We are a big city. We have urban stressors on our streams and in our watershed. So we're at the bottom of a very large watershed, the Delaware and the Schuylkill watersheds. So we don't really have control of everything that's coming down. And I'm sure many of you already have an understanding of watershed mechanics and how things flow from upstream to downstream. So we're the recipient of a lot of things coming down to us. Being a large utility, we have a very long timeline for planning and construction. So when Dr. Kabuye was mentioning the 5 years for utilities to comply with PFAS, that's not a lot of time for us to try to update and upgrade our large drinking water plants that were built in the 1960s. And if you were to ballpark a price tag for PFAS for the water department, we're talking about $2 billion. So this is a very huge issue for us. Here's just kind of an overview of what I'm going to talk about with respect to how we're handling PFAS. We're going to talk about a little bit about how we monitor and research these chemical compounds. how we're handling our public messaging. I'm here with you today. We're trying to be very transparent about how we address PFAS. We want to talk about it. We, as I said, are in a very large watershed, so we coordinate regionally with our other partners in the watershed. I'm going to talk about how we're reacting to these regulations from the PA, the EP, and EPA, how we're planning to address the compounds through planning and piloting new technologies, and then touch a little bit on the litigation that we have with the chemical companies that are involved in a multi-district litigation with many municipalities and utilities across the country. And that is a picture of my colleague taking a PFAS sample at our Baxter treatment plant on the Delaware River. So you've seen this slide. Dr. Kapiya had the very same one. So I'm not going to go over it again, but I just want to highlight in this slide that PFAS truly are forever chemicals. They cycle through our environment, and that water treatment plants, wastewater or drinking water, are pathways for PFAS. We don't create them, but they cycle through as a constituent that's very soluble in water. One of the questions, and this is just still kind of just giving a little bit more background, one thing that comes up is if these chemicals have been around since the 1940s, why are we just now learning about them? Why are we learning about their detection, their toxicity? And it's because we have these liquid chromatography and mass spectrometry devices that we can now detect these compounds down to the parts per billion level. And also credit to Penn State Extension for this really nice graphic. A lot of people, it's hard to visualize a part per billion. It is one droplet of water in 20 Olympic-sized pools. So another thing is that we also will be, I'm sorry, part per trillion. I misspoke, not part per billion. And part per trillion is interchangeable with another unit of measure, nanograms per liter. So we may refer to the concentrations in either nanograms per liter or parts per trillion. And also, we touched on the analysis methods a little bit, but just to say that there are EPA-approved methods that let you detect, say, 14 compounds. There are also non-targeted analysis methods that let you detect a total number of compounds, but doesn't differentiate between the individual species. And just to give you an idea, sometimes we're looking at a test that tells us about 14 different compounds, but we know that there are more than 15,000 different types of PFAS compounds out there. Can we remove PFAS from water? We can. Dr. Kapiya also mentioned some of these treatment methods. Again, our plants were built in the 1960s. They were not designed to remove PFAS, so that conventional treatment does not remove PFAS, but there are 3 approved methods for doing it. One is granular activated carbon, and it's very analogous to your Brita water pitcher filter, where carbon adsorbs the PFAS compounds. Reverse osmosis, which is passing the compounds through a membrane, and then ion exchange, which uses the positive-negative charge of the compounds for removal. There's 2 things that all these treatment methods have in common. A, they're very expensive. B, they are very energy intensive. So when we were talking about a carbon footprint or our greenhouse gas emission goals for our plants, one way to blow those out of the water is to install expensive and energy intensive PFAS treatment. Similar to a slide you saw before with the USGS data, the DEP also did statewide testing throughout Pennsylvania and just to survey and see where the PFAS concentrations occurred. Similarly to the previous map that you saw, you can also see that mostly in the more populated urban areas, you're going to see more PFAS occurrence. Drinking water regulations also previously covered. One thing that I want to highlight is just what an MCL is. It is just the maximum amount of that contaminant that can be in your drinking water. And the way that it's enforced is that it's a combination of the risk to human health and the feasibility of removing it from the water. So again, with PFAS, it was kind of an unusual situation where the states were often the first to act on making regulations for PFAS. So Pennsylvania came out with their regulations first. About a year later, the EPA came out with even more stringent regulations that will eclipse or replace the state regulations. So again, those two big compounds that we're looking at mostly are PFOA and PFAS, and the MCL is set for 4 parts per trillion, which for all intents and purposes is practically 0. And we must achieve compliance by 2029. Under the last administration, the EPA issued a PFAS roadmap, and it was a very nice document. It was very broad. Want to mention that the Philadelphia Water Department supports the maximum contaminant levels for PFAS in drinking water. The EPA focused on several different areas, including source control and manufacturing, trying to limit the production of these compounds. I do have to say that there is no ban on PFAS production. They have started by addressing the occurrence of PFAS in drinking water, and that includes the MCLs that we're mentioning. What's happening kind of now is more in the wastewater realm, where we're starting to see that the EPA is limiting the or starting to monitor the occurrence of PFAS in wastewater and wastewater discharges. Surface water, we're still kind of trying to get a handle on what will be coming down the pike with ambient surface water quality criteria. And Dr. Kabuye mentioned the fish consumption advisories. The only one I'm aware of in Pennsylvania that has occurred is Neshaminy Creek in Montgomery and Bucks County. That was the only one I was aware of. And then we're seeing a lot more on the waste stream and residuals regulations. Public messaging has been a big part of our strategy to address PFAS. If our customers don't hear from us first, they're less likely to trust us. So we've done as much as possible to put our information out there. We do have a web page dedicated for PFAS that includes all of our drinking water results that we've tested for. We have different studies that we've conducted to put those results in context. So that includes both the drinking water and surface water results, and trying to explain this to people who are concerned about their drinking water quality. One thing that always comes up is the word safe. Is your drinking water safe? And I'm here to say that we do say our drinking water is safe. The definition of safe is not 100% pure or risk-free. Do you feel safe walking out of your home and breathing the air? A reasonable person would say yes. Are there contaminants in the air? Yes. So in terms of whether your drinking water is safe, we maintain that it is. We test for PFAS. I'm sure, as you all know, bottled water is unregulated, untested. So by putting that information out there, we're hoping that we can engage in a conversation with our customers who may be concerned about PFAS. So as I mentioned, we have been monitoring for PFAS, and we have 3 drinking water plants, Baxter on the Delaware River and Queen Lane and Belmont on the Schuylkill River. These are the results of our PFAS testing for those 3 drinking water plants. You can see that Queen Lane and Belmont have detections above the 4 parts per trillion or nanograms per liter proposed MCL. So why is that? Queen Lane and Belmont on the Schuylkill River, which is a much smaller river than the Delaware, which provides a lot more dilution for PFAS. So you can see even at Belmont, we are barely, not even 2 parts per trillion over the limit at this point, and we have until 2029 to comply with those regulations. We first became kind of really engaged with PFAS back in, say, 2016. And if any of you are in the Southeast Pennsylvania region, you will probably have heard of the contamination that occurred with the groundwater near the Willow Grove and Horsham Naval Air Bases. Basically, they used AFFF, which is firefighting foam, in a training facility for these bases that seeped into the groundwater and had long-lasting effects for the groundwater drinking water supply for that area. So this is kind of up north of where Philadelphia is, but it is in our watershed. So this was one of the things where we heard from our neighboring utilities that, hey, you should really look into this. And I'm just saying this as a pretext for what we did afterwards. We engaged with a study to find out how those chemicals were being transported down to our source waters. So that was via the Pennypack Creek, which has its headwaters near those bases. So we did a study to track how the chemicals were coming down, how were they being diluted. Our motto, our mantra here is that we want to prevent pollution at the source. We don't want to have to treat it once it reaches our plants. So this is just an example of a study that we did along the Pennypack Creek. So you can see the yellow dots here are potential sources of PFAS, and that includes wastewater treatment plants as well as the naval air stations. And the red dots are our monitoring stations moving down the creek. And we saw exactly what we expected, a nearly monotonic decrease as we moved downstream. So from the upstream site, pretty high levels of PFAS, and then as as we move downstream, we see dilution and we see decrease as we move further away from the source. And the Pennypack Creek is a very minor influence on our Baxter water treatment plant on the Delaware. The Delaware River flow dwarfs the Pennypack influence. So as I mentioned before, we are looking at different treatment technologies in order to remove PFAS from the water. We are required by the Department of Environmental Protection to pilot treatment options for 1 year before they approve it. So again, we are looking at the granular activated carbon and the ion exchange methods of removal. We're not looking at reverse osmosis just because of the expense. It's just kind of out of our range. And along with removing PFAS, we're seeing what else can these treatment technologies do for us? Can they remove other types of pollutants or chemicals that we may not even be regulated on yet? So what that looks like is we try to, move as much water through these filters, through these processes, and see what works. And again, I mentioned the expense. If the Brita water pitcher filter is kind of a good analogy, because if you think about, how often you are, conscientious about changing your water pitcher filter, and then you go to the store and you see the 3-pack of Brita water filters is nearly $30. Now think about the amount of carbon and granulated activated carbon you would need for a water utility, where you're talking about hundreds of tons or thousands of tons per year, and the cost and the storage and the things that you would need to do to implement that kind of treatment on that scale. Along with just the cost of the thing, this is an aerial view of one of our treatment plants, and sometimes we just don't have a place to physically put the treatment system. So we're kind of space limited. So we have a lot of different challenges in trying to meet this compliance deadline. And then I just want to end by kind of saying what's kind of on the horizon, what are we looking at next? And the first thing that we're looking at is going beyond those handful of compounds that are regulated right now, specifically PFOS and PFOA. Those are known as legacy compounds. There is a second generation and even a new generation of PFAS that are being produced. Think of those 15,000 chemicals, not just the 14 that we're looking at with one of the EPA methods. So the EPA is coming out with more toxicity studies to represent the array of compounds that we're experiencing. We can expect that as our detection methods get better, we may see a lower MCL. And we want to also look at the effects of mixtures of compounds. Instead of looking at how one compound affects human health, how do mixtures and combinations of different compounds, have a different kind of toxicological effect? I mentioned biosolids briefly. So if you don't know, biosolids are made from sewage sludge for land application for mainly agricultural purposes. In the past, this was seen as a win-win. This is beneficial reuse of sewage sludge. But now that we know that PFAS can cycle into the biosolids, farmers are understandably more reluctant to apply this to their land because PFAS can be taken up by plants, can be absorbed through farm animals, and getting into the food supply. So you may have seen this New York Times article from maybe a month or two ago. There's a lot of scrutiny on the biosolids industry to limit the amount of PFAS present in biosolids. And the EPA has moved to classify PFAS and PFOA as hazardous substances under CERCLA, basically the Superfund Act. So the EPA has said that they do not want to hold pathways such as water utilities accountable in the same way that they want to look at industrial polluters. So we're still kind of waiting to see how that plays out in terms of the whole industry and the whole landscape of where biosolids are applied. And then finally, what's next? I think we'll be looking at PFAS everywhere else. Definitely in food products, which provide a substantial amount of human exposure. Definitely the states are leading the way, again, with individual regulations and legislative proposals to limit PFAS in food packaging, cleaning products, consumer products. And then another thing that has come up sort of more regionally here in Philadelphia is the presence of PFAS in synthetic turf. The newspaper, The Inquirer, did a series on how the old turf in Veterans Stadium in the 1980s may have affected the Philadelphia Phillies players who played on that turf. And then also some discussion, even more locally, our local rec centers that use artificial turf for playgrounds, how that may be affecting health, and testing those products before they are constructed on public land. And that is it for me. That's my email address there if you have questions. And I think I will just end here and leave us some time to have some questions. Tom, I think you're on mute there.
There we go. Thank you, Matt, for a comprehensive presentation on what this city is doing. And I think some of the questions have been answered in the chat, but I'll go through some. By the way, Matt, are you willing to share your slides with the audience? A PDF or something like that?
Yes, I should be able to do that.
Okay, yeah, then you just, Faith is also willing, so send it to me. I'll send it out to all the registrants of the this webinar. And so let's jump into the questions. One is that, you know, there are thousands of PFA and PFOA chemicals. Is the and you know, certainly EPA is not regulating all of them. Is the number of chemicals which are being regulated now, do they represent the sort of a threshold where you, by controlling to meet those limits, you automatically reduce PFOAs and PFAs and other chemicals which are not being regulated?
I would say there is no way of knowing that. I would not agree with that necessarily.
Okay.
And I think the issue with not being able to know about the thousands of other chemicals is that often these are proprietary formulas held by private industry. We don't have the standards or kind of like the fingerprint, the chemical fingerprint of these compounds in order to be able to detect them. So we're looking at compounds that have existed, since the 1960s. And even some of the newer compounds that we hear about, such as Gen X, those have been well known for decades. So the industry has moved on to even newer compounds that we don't necessarily know about.
Okay, good. Here's another questions about testing in streams and other bodies of waters. The places you test are your water plants where, I guess, finished water is sent into the mains for distribution. So these are the only places that you test as a water utility?
No, we've tested everything from small streams upstream of us all along our source water continuum in our watershed. We test at the intake to the plant, in our raw water storage, and at the output to the plant going into people's, into the distribution system.
Okay. And you mentioned about bottled water not being tested as well. Does bottled water pick up PFAs from the containers?
It is possible that plastics contain some amount of PFAS, but I think the gist of that point is that bottled water is not required to test for PFAS. It's natural. It may be naturally occurring, not naturally, it may be already occurring in their sources. So whether they source their bottled water from another municipal source or a groundwater spring or another natural source, it is likely that PFAS already occurs.
Okay.
So I wanted to add that bottled water is regulated by an entirely different body. It's regulated by the Food and Drug Administration and not the US EPA. So utilities are meeting US EPA standards, but for the water bottle companies, it's at their discretion. They may decide to try to meet the US EPA standards, but their body is not requiring them to meet those MCLs.
Okay, thank you for that addition. I was not aware that when they bottle the water, there's no testing for PFAS going on. Okay. There's a question from you about well water. You mentioned about how this is, where do I go to get my well water tested that doesn't have a conflict of interest?
Yeah, so I did try to type a response to that, but I can also talk about it a little bit. For private water systems, it's all your responsibility to do all of this, unfortunately. So Pennsylvania DEP have some certified laboratories for PFAS testing, and you could find those on the EPA DEP website, but we at Penn State Extension have also summarized the currently certified laboratories for PFAS testing. But I'll also add in the chat where to go if you want to search on the PADEP website. And testing can be expensive, but the services are available. And sometimes we have programs for free water testing at Penn State Extension. So if you are a Penn State Extension subscriber, stay tuned. Once in a while, you might be part of a research project that is monitoring for PFAS and other unrelated contaminants in private water systems.
Okay. You mentioned also that you could treat your drinking water from your tap and so forth. Does it make any sense to, if you're in a certified public utility, water utility, to have a further type filter as well?
I would say people who want to reduce their exposure, I think that's a great idea. It's a personal, a personal choice. I want to be clear that home filtration systems such as a water pitcher will not remove PFAS completely, but they can reduce some of the concentration.
Okay. And are there, better ways of treatment at home than others? You mean like the whole house water systems?
Yeah, there are reverse osmosis systems that people install in their homes. Usually that happens in areas where there's a lot of contamination, and naturally those things can be very expensive. So, I can't speak as to the efficacy of those systems. I don't really know, but if people are interested in, they can look into that.
Yeah, thanks, Matt. I wanted to add that if you're purchasing any treatment device for the sole purpose of is making to make sure that they are accurate. So if they have that certification, they've been tested at least by a third party that's not the business that's selling that product. But I'm also going to put in the chat a particular fact sheet that we put together for different treatment devices that are available for point of use and point of entry PFAS treatment. But the most important thing when you have these is that you have to maintain them in order for them to do what they're supposed to do. Otherwise, you might just have an expensive system in place, but if you're not maintaining it properly, it might not be serving what you intended for it.
Okay. And the final question is, Philadelphia Water Department and other utilities pursuing litigation against the sources of PFAS that come down to the water supplies?
Yeah, so I did mention this multi-party litigation against DuPont and 3M. So both of those cases came to settlement, and we opted out of the DuPont settlement, which was around $2 billion. The 3M settlement came to something like $12 billion. I want to say. Apologies, that's off by $1 billion or $2 billion. But that money is split amongst hundreds of municipalities and utilities throughout the country. So it's kind of like the equivalent of a class action lawsuit kind of thing. And just to say that even with whatever money we may be receiving, it is a very, very small fraction of what we would need to expend to address the PFAS contamination.
Thomas,
Great.
Bob has his hand up.
Oh, go ahead.
Yeah, I'm typing in the chat right now. I have a private well with very terrible, nasty water. And I don't know that I have PFAS, but what I can share with you is I'm going to type into the chat. Someone asked there along the way, where can you get your water tested? There's a place called Analytical Laboratory Services, Inc. And it's, well, I know there's an office there on Progress Avenue.
In Harrisburg.
And they are funded or in some way associated with DCNR. I know one of the people who work there, and I had to ask him about what he does there and so forth. So I've learned a little bit, but I haven't done several tests there. And I have not asked them to test PFAS, but they do all kinds of stuff, more than what you're. See, what I have here is to treat my water, I have a water treatment system that they put in homes. Okay. And so they will test your water. I don't know that any of them typically can test for PFAS or not, but I had gone to this company myself just to get better, more accurate results for iron and other things that I had issues with. So I'll put the name in the chat, and I have an address here. It's actually a Middletown address. So I'm not sure I know the office where I would drop my water sample off was on Progress Avenue, Harrisburg. But anyway, one question I did ask my person who does the maintenance and so forth and installation, the guy who comes to your house. I do have reverse osmosis, and I ask, is there, when you have reverse osmosis, it's a like a box type unit, and they hang multiple small canister filters in there, and they did not have one to remove PFAS. But an interesting thing here, Faith, you mentioned, I believe it was you mentioned that maybe both of you have granular activated carbon. We'll remove that. I think I'm using exactly that to remove odor from my water. I have a 4-foot high canister tank filled with that carbon, which after a while needs to replace. And I think that's what it is. So that's not reverse osmosis. That treats all of my water, going through the pipes. And that thing is filled with carbon, black carbon granules. Is that the same thing? Either you, Matt, or Faith, do you know? I'd have to I'm digging through my papers here. I don't have that one in front of me, but I believe that's what I have. Is it something, do you know, is that something a homeowner can actually have installed?
I can't say whether your exact media is granular activated carbon or powdered activated carbon or some other carbon media. So I don't want to characterize it as it is, but yes, the same carbon that is used for taste and odor compounds can remove some PFAS compounds. So yeah, there is some adsorption happening.
Yeah, I'm quite sure.
That's all I can say, not the amount of it or the efficacy of it, that there is probably something happening.
Yeah, okay. I'm quite sure they always referred to it as granular, but I can check on my invoice or something and see here too. Then when I
okay. Well, thank you. Yeah, our time is up at we're close to 1 now. I want to thank you, Matt and Faith, for a really interesting presentation. I've learned a lot about treatment and sources and how difficult a problem this is. And one reminder is that, as Matt said, you also have to look at the sources of PFAS coming downstream, and we need to do a job of controlling those sources. And that's certainly something that we can think about as advocacy to EPA, more restrictive limits on PFAS and the discharges from industrial sources. Thank you. I'll try to include all the information that we've been presented in notes today, and we have a recording for those who have missed this session. Again, thanks, Matt and Faith. Wonderful job.
Yes, thank you.
Thank
Thanks
you.
so
Thank you
much.
for your interest.
Yeah, thanks
Thank
for
you
having.
very much.
Yeah.